We're going to look at the graphs of trig functions. This is a switch from using the xy axis for the unit circle to thinking about the xy axis as the more traditional sense, where we have independent variable x that we put on the horizontal axis and dependent variable y that we put on the vertical axis. We're going to use x to be the angle measure, and then y will be the trig function value that's evaluated by putting that angle measure into the trig function. We'll start with y equal cosine x. So I have several values for angles listed there for x. We're going to plug those into the cosine function of the unit circle to help us do that. Multiples of pi over 4, going from negative pi to 2 pi. So let's start off with y equals negative pi. So using our unit circle, negative pi is going in the clockwise direction. We get to the negative y-axis. The point that corresponds to that angle is negative 1, 0. Cosine is going to give us the x value. So plugging in cosine function value for negative pi, we get a negative 1. Now let's look at negative 3 pi over 4. So again, we're going in the clockwise direction for the negative angle. If we go to negative 3 pi over 4, here's 1, 2, 3. This is the point that corresponds. We're picking up the x value, so it is negative square root 2 over 2. The next value of x is negative pi over 2. So we're again going in the clockwise direction. Negative pi over 2, we get to this point. Here is our point that we're going to use to evaluate, and the x value is 0. So that goes in for the cosine function value for when the angle measure is negative pi over 2. Now, negative pi over 4. So clockwise direction, we get to this angle. Here is the point that's going to give us the cosine value, and we have got a positive square root 2 over 2. X equal to 0, so that's just right here. We pick up the cosine value is 1. Pi over 4, right? We get this angle here. Cosine value is square root 2 over 2. For x equal to pi over 2, our cosine value is 0. For x equal to 3 pi over 4, all right, we're going to this angle here. We pick up the cosine value of negative square root 2 over 2. For angle of pi, our cosine value is negative 1. For 5 pi over 4, our cosine value is negative square root 2 over 2. For 3 pi over 2, cosine value is 0. For 7 pi over 4, our cosine value is square root 2 over 2. And for angle measure of 2 pi, our cosine value is 1. Now let's plot points. We have negative 1, 0, 1, square root 2 over 2, and negative square root 2 over 2. Let's evaluate square root 2 over 2 and get a decimal form. Well, if you plug that into your calculator, it approximately will be 0.707, or approximately, let's just go with 0.7. So if we put that on our x or our y-axes, we're going to have 0.7 and negative 0.7 as function values that we will want to be able to plot. Plotting points: negative pi, negative 1, negative 3 pi over 4, negative square root 2 over 2, negative pi over 2, 0, negative pi over 4, square root 2 over 2, 0, 1, pi over 4, square root 2 over 2, pi over 2, 1, 0, 3 pi over 4, negative square root 2 over 2, pi negative 1, 3 pi over 4, negative square root 2 over 2, 3 pi over 2, 0, 7 pi over 4, square root 2 over 2, and 2 pi, 1. Now connecting those points in a smooth curve, we get what we call the cosine wave. The cosine function, and we'll find out the sine function as well, are what we call periodic, because the same values for the function keep showing up. So we get square root 2 over 2 every time we have a multiple of pi over 4 that is giving us a positive cosine value. We get negative square root 2 over 2 every time we have a multiple of pi over 4 that gives us a negative cosine value. Let's look at characteristics of this cosine function. The domain is all real numbers. There's no values that we can't put in to x. There's no angle measures that are going to give us an undefined or not real cosine value. What about the range? Well, we do have minimum points right here, right here. If we continued in either direction, we would also get that same minimum point, which is -1. So it's included, we use a bracket. Maximum point, we've got +1, and again, if we extend it to the left and the right, we would continue to get that +1 function value showing up. So it's included, we use a bracket on that end. So the range goes from -1 to +1 inclusive. Now, period, this comes from the fact that it's a periodic function. We want to identify the length of the pattern that gets repeated. So the pattern that gets repeated, from here, we go from x equal to -pi, where y is -1. All right, it takes on all these function values and then returns to y equaling -1. So what is the distance of that? What is the length of that interval? Well, it goes from -pi to +pi, so that's 2pi. So the period of this function is that length of the repeating pattern, that is 2pi. Amplitude is the distance from 0 to the maximum or minimum point of a periodic function. So let's go here from the x-axis where y is 0 up to one of those maximum points at y equals 1. Well, that distance is 1. That is the amplitude. Now, asymptotes, we know when we studied rational functions and exponential and logarithmic functions in their graphs. That is a value of y that the function approaches as x goes to positive or negative infinity. Because we have this oscillating periodic function, there is no asymptote. So no asymptote for the cosine function. So I want to point out that the angle measures that are in quadrant 2 or 3, which is where x values are negative or cosine values are negative, such as -3pi over 4, -pi, -5pi over 4, +3pi over 4. Those correspond to where the graph is below the x-axis, where we have negative function values. And in quadrants 1 and 4, where cosine values are positive or x values are positive, that corresponds to where the graph is above the x-axis, where the function values are positive. We are now going to look at the graph of the secant function. So let's look at y equals secant of the angle x. So we want to remember that secant is the reciprocal function of cosine. So we are going to be able to use these cosine function values that we came up with and just simply take the reciprocal. So if we start with x equal to -pi, the secant function value is going to be the reciprocal of -1, which is -1. For x equal to -3pi over 4, we want the reciprocal of negative square root 2 over 2. So if we flip that over, we get -2 over square root 2. If we rationalize that denominator, multiplying by top and bottom, square root 2, we end up with negative 2 square root 2 over 2. The 2's cancel. So the reciprocal of negative square root 2 over 2 is negative square root 2. For negative pi over 2, the cosine value is 0. Well, if we take 1 over 0, that is undefined. So the function value for when x is equal to negative pi over 2 for secant is it does not exist. All right, for negative pi over 4, we're going to take the reciprocal of square root 2 over 2, which is square root 2. For x equal to 0, we take the reciprocal of 1, which is 1. For pi over 4, we take the reciprocal of square root 2 over 2. For pi over 2, our cosine value is 0, so that means our secant value is undefined. For 3 pi over 4, we want the reciprocal of negative square root 2 over 2. For pi, we take the reciprocal of negative 1, which is negative 1. For 5 pi over 4, the reciprocal of negative square root 2 over 2, which is negative square root 2. For 3 pi over 2, again, we are going to take the reciprocal of 0, so it's undefined. For 7 pi over 4, the reciprocal of positive square root 2 over 2. And for 2 pi, the reciprocal of 1, which is 1. All right, let's graph y equals secant x. We're going to plot points and connect with a smooth curve. We have some function values that do not exist. For those values of x, that's where we have a vertical asymptote because those values of x are not included in the domain. So at negative pi over 2, pi over 2, and 3 pi over 2, we're going to have vertical asymptotes. From our section on rational functions, we know that when we've got a vertical asymptote, as x approaches those values of x, the graph will go to positive infinity or negative infinity. Let's plot the other points now. At negative pi, function value is negative 1. At negative 3 pi over 4, function value is negative square root 2. At function value negative pi over 4, function value is square root 2. At 0, function value is 1. At pi over 4, function value is square root 2. At 3 pi over 4, function value is negative square root 2. At pi, it's negative 1. At 5 pi over 4, it's negative square root 2. At 7 pi over 4, it is positive square root 2. And at 2 pi, it is 1. All right, so if we connect these points, we're going to use our definition of vertical asymptote. We're going to connect these points, and as we approach this vertical asymptote from the right, we are, from the left, we are going to go to negative infinity. And then we've got these 3 points in between these two asymptotes. As we approach from the right, we're going to go to positive. And we go to positive infinity here. For these 3 points, we're going to go to negative infinity as we approach those asymptotes, and here we go to positive infinity. Now, we didn't plot points on either end here, but it's going to follow the same pattern as we have. Let's look at the characteristics of the secant function graph. The domain is not all real numbers. We are excluding from what we have graphed, we are excluding negative pi over 2, pi over 2, 3 pi over 2. So the distance in between each of these is a length of, so the values of x that are being excluded are pi over 2, and anytime we have a multiple of pi added to or subtracted from pi over 2. So n is an integer, positive or negative integer. Now that also gives us the asymptotes. So the domain is not including those values of x. The asymptotes are those values of x. Let's look at the range. Well, the range is all values of y, excluding the values in between negative 1 and 1. So we go from negative pi up to and including negative 1, union with positive 1 to positive infinity. The period is the length of that repeating pattern. Well, we have a repeating pattern here. So the length of that is 2 pi. though we put in the period of 2 pi. And we do not have a wave like we do with the cosine, so there is no amplitude. Now let's look at the trig function tangent. So y equals tangent x. Now remember that using the unit circle to evaluate tangent of an angle, we take the y-coordinate of the associated point over the x-coordinate. So we'll use that to find these trig function values. So for negative pi, we are going to take 0 over negative 1, which is 0. For negative 3 pi over 4, right here, we take negative square root 2 over itself, so that's going to be a positive 1. For negative pi over 2, we have negative 1 over 0. Well, that is undefined. For negative pi over 4, right, we're right here, we've got a negative square root 2 over 2 over positive square root 2 over 2, so that's going to be a negative 1. For x equal to 0, we will have 0 over 1, or 0. For positive pi over 4, we have got a positive square root 2 over itself, so that's a positive 1. For pi over 2, we're going to have 1 over 0, so again, that's undefined. For 3 pi over 4, we get square root 2 over negative square root 2 over 2. That's a negative 1. For pi, we've got 0 over negative 1, so that's 0. 5 pi over 4, negative square root 2 over itself, that's going to be a positive 1. 3 pi over 2, negative 1 over 0, we have another undefined. For 7 pi over 4, we've got negative square root 2 over positive square root 2 over 2, so that's a negative 1. And for 2 pi, 0 over 1, or 0. Now we're going to sketch the graph of tangent x. First thing to do is put in the asymptotes at negative pi over 2, positive pi over 2, and 3 pi over 2. Now let's plot the points. At negative pi, we have a 0. At negative 3 pi over 4, we have a positive 1. At negative pi over 4, we've got negative 1. At 0, it's 0. At positive pi over 4, it's a 1. At negative 3 pi over 4, it is a negative 1. At pi, it's 0. 5 pi over 4, it's 1. At 7 pi over 4, it is negative 1. And at 2 pi, it is 0. Connecting those points, we use the asymptotes as a guide. As we approach those asymptotes, we either are going to positive infinity or we are going to negative infinity. So we follow where the points are and draw curves through those points, approaching the asymptote, either going to negative infinity or positive infinity. Looking at characteristics of the tangent function graph, the domain is going to exclude those values of x where we have asymptotes. So we are going to exclude x not equal to pi over 2, and then again the difference between, or the length between those two, or where the asymptotes are, is pi. So we will exclude pi over 2 plus multiples of pi. The range is, well, there's no restriction on the range, so negative infinity to positive infinity, because we are going here, negative infinity to here, which is going to positive infinity. The period is that length of that interval of values of x where we repeat the pattern. Well, the pattern is repeated every length of pi. So this has a period of pi. Amplitude does not apply here. And then asymptotes are those vertical lines where x is excluded from the domain. So x equals pi over 2 plus n pi.